Uh, Morning, grade 10s. Let us now look at question 7, which is our analytical geometry. I will just zoom here so that you can see the question. Refer to the stick figure, question 7.1, which is Joe, below to answer the questions that follow. Now, if you look at this stick figure there, you can clearly see there are coordinates given for Joe. Now, they want the length of Joe's leg, which is ED, distance from E to D. Now, if we look at the distance from E to D now, what we are going to do here, let me just use a color here just to highlight which part are we talking about. Distance from here, from E to D, which is this line here. We want the distance from E to D. Now using coordinates, I can, okay, say this is my X1, Y1, and I can name these ones here my X2, Y2, using the distance formula. Now we want the distance or the length of ED, 7.1.1, using the distance formula, distance ED should be equals to the square root of, there we will have the distance being x2 minus x1 squared. That is our distance formula. Plus, this is our y2 minus y1 squared. Then all we have to do is to substitute. Let me just correct this square here so that we can all see the square. X2 minus x1 squared. Therefore, ED equals to, then all I'm going to do now will be to substitute. What is my x2 according to the choice there? It is 2. And then what is my x1? It is 5. So 2 minus 5. Then my y2 according to my choice there, it's minus 4 minus 7. Let me just delete here. It's minus 4 minus 7 squared. Minus 4 minus 7 squared. This is our minus 7. Therefore, moving step by step then, 2 minus 5 will give me minus 3 squared. This negative times negative, it will be positive. Then we'll have minus 4 plus 7. Minus 4 plus 7 will give us positive 3. All squared. Minus 3 squared will then, if you square minus 3, you'll then end up with positive 9. You'll then end up with positive 9. And you square positive 3 will also give you positive 9. Therefore, 9 plus 9 is 18. So we have the square root of 18, which can be written in a simpler set form as 3 square root 2. So that is the length ED. That's what we are looking for, length ED for 7.1.1. So using the distance formula, that will be our distance for ED. Now, we need to look at the next question. Here they're saying, determine what type of triangle is triangle CDE. Determine what type of triangle CDE is. We want to know what type of triangle is triangle CDE. Now you'll realize that when we calculate, we are looking at this triangle CDE. When we look at CE, let us find the distance CE. You'd realize that the distance from C to E using the distance formula. Let's see now our CE. We are focusing on CE. If I call these coordinates here, let's say this time for this one, x1, y1, and here x2, y2 still. We are now focusing on line CE. Let us also use the distance formula. That line CE, let's just see, 7.1.2. CE using the distance formula should then be square root of x2 minus x1 squared plus y2 minus y1 squared. Then we can substitute. We have our x2 according to our choice on that CE, our x2 there, it is 2 minus our x1, which is minus 1. So allow me to say it will be 2 minus minus 1, which will end up being 2 plus 1. Then the coordinates, y2 is minus 4. And then y1, it's minus 7. So it will be minus 4 plus 7 squared. This end up being 3 squared plus 3 squared. So what we can clearly see here, you'll end up getting 9 plus 9, which will be equals to square root of 18. In a simpler set form, square root 18 is 3 square root 2. So we are looking at distance CE. Now what we have discovered now is that CE is 3 square root 2, and we also found ED to be 3 square root 2. So what we have discovered is that CE is equals to ED. Possibilities are the third side can also be equal, but in this case, you can clearly see the third side, which is CD, it is horizontal. So the distance from C to D, you can clearly see using only the X because the line is horizontal. I can just work with the X coordinates. It will then have to be 5 minus minus 1, which will give me 6. Now let's see. Our distance CD should then be, allow me to just say x of D minus x of C. X of D, if you look at x of D, there it is 5 minus x of C, which is minus 1. This times this is positive. It ends up being 5 plus 1, negative times negative. So CD will then be equals to 6. Now what we have discovered now, in this diagram, we have discovered that CE is 3 square root 2. Even ED is 3 square root 2. Whereas, what we have discovered now, let me just use a different color. What we have discovered in this case now is that these two sides are equal in this triangle. Side CE is equals to side ED because both of them are 3 square root 2. Even here is 3 square root 2. Whereas this one here, it is 6 units. So when you are given a triangle and you have two equal sides, which triangle is that we are going to say this triangle, it should then be an isosceles triangle. Reason being, two sides of this triangle are equal. So we are going to write here now. Let us conclude that which type of a triangle is that triangle? We were talking about triangle CDE. Therefore, triangle CDE is an isosceles triangle. It's an isosceles triangle. Reason being, what is our reason? Reason being, we have proved that ED, that's our reason, equals to CE. It has two sides that are equal, which is ED and CE are equal. That was question 7.1.2. Now look at question 7.1.3. They want the gradient of EC and ED. Now let's look at EC and ED, their gradient. Now when we look at 7.1.3 there, 7.1.3, we want the gradient of, let me start with ED, then it should be y2 minus y1 over x2 minus x1. Remember your ED, the coordinates for ED. Remember your ED, the coordinates, it's 2 minus 4, 5, and minus 7. So those are the coordinates of ED. So y2, from there, if I say this is my x2, y2, x1, y1, what will we get there? Y2 minus y1. Now let's see. We will then get minus 4 minus 7 all over x2 minus x1. My x2, it is 2 minus 5. So we will then end up with this negative times negative, it's positive 7. So minus 4 plus 7 will give me 3, and 2 minus 5 will give me minus 3. Therefore, gradient ED equals 3 divided by negative 3, it's negative 1. So gradient ED will be negative 1. Let us now look at gradient EC. The gradient of line EC, using again the gradient formula, gradient equals to y2 minus y1 over x2 minus x1. Remember your EC, you having your C with coordinates. You having your C with coordinates here, minus 1, minus 7. You having your E with coordinates 2, minus 4. Saying this is your x2, y2. If we say this is our x1, y1. So what will we get here? We will then end up with substituting y2, which is minus 4, minus y1, which is minus 7, over x2, which is 2, minus x1, which is minus 1. So we will end up with negative times negative, so minus 4 plus 7. And down here also negative times negative, 2 plus 1. So we will end up with minus 4 plus 7 is 3, 2 plus 1 is 3. So we will get the gradient to be 3 divided by 3, it's 1. Gradient of line EC. Now we found the gradient of line EC and we found the gradient of line ED. Then what is the next question they are asking? Let's go back to our paper. Now looking at our questions there. Question. We are now looking at question what? We need to look at question 7.1.4. Now, if you look at question 7.1.4, let's just look at it here. I'm trying to retrieve it. Yeah, 7.1.4, hence determine with reasons the size of angle alpha. Now, let's look at the angle alpha where it is positioned. Allow me to erase here. Our alpha. There we are. All right. Let me just get a different color again. So we must use line EC. Alpha there, we can clearly see there, our angle alpha. It is the angle of inclination for this line, EC. So here it's our angle alpha. Now, to answer that question, we're going to find in the angle of inclination for line EC. There we are. If I look at the diagram, if we were to look at this as our x-axis, here is that angle of inclination, alpha. Then we have our point E, and then we have our point C. Now, angle of inclination, tan 6.1.4, tan the angle of inclination equals to the gradient of that line segment, which is line segment EC. So tan angle of inclination of EC equals to the gradient of EC. And we found the gradient of EC to be equals to 1. Tan alpha equals to 1. Therefore, alpha equals to tan inverse of 1, which gives me tan inverse of 1, which gives me 45. So we found our alpha there now to be equals to 45. That's how you'll answer question 6.1.4. Grade 10, that's how we will go with this question. My mistake, I'm saying 6, I keep on saying 6, and these questions, it's not question 6. We are doing question 7. Not question 6, but question 7. So it's question 7.1.4. Can we look at, yeah. So we were in question 7, from 7.1.1 to 7.1.4. So those are your solutions. That's how far we will go with this question 7. Now, I will stop it here. We will now look at part 2 of this paper. Let me just stop this clip here for the first part of this analytical geometry.